Hello, my name is Rustam. Welcome to this talk on automating podcast localization using OpenAI's API stack. In this talk, we will explore how to convert English podcasts into Russian while maintaining tone and style. We will go through architecture, technical challenges, and real examples. Let's get started. The main question is why we want to automate podcast localization, and there are two main reasons. The first reason is to make content accessible to a wider audience. Podcasts which are only in English can now be consumed by Russian-speaking people without any knowledge of English. The second reason is to reduce manual effort while ensuring high-quality results. In other words, automation makes it simpler to translate podcasts without human intervention. While doing so, we want to maintain tone and style in translation, and GPT-4o helps with that by allowing us to translate English-speaking speech to Russian while preserving the original tone and style. Solution overview. Here is the overall structure of our localization system. Each step plays a critical role in transforming an English podcast into a Russian one. The first step is podcast downloader, where we download the podcast metadata such as title and description and the MP3 file. And then there is a second step, transcription. We have to transcribe this MP3 file into a text. And then text processing, we give this text to process into GPT-4o model. The processing includes adding all the punctuation marks, fixing all the grammar, and so on, so that the speech sounds more natural, sounds more live. And then we have speech synthesis, and here is where we take the TTS1 model and produce the Russian track on this translated text. Then audio assembly, and this step is needed because when we use TTS1 model, it has a very small restriction in about 4,000 characters at once. So we can only give it to 400 characters to make an MP3 track from it. And if the podcast is long enough, we have to split the podcast into multiple chunks and then merge these audio files. And the next step is RSS generation, where we generate an RSS feed, which is then consumed by podcast platforms, and they can check this RSS feed later on and see that if there is a new podcast, then there is a new episode of a podcast, they add it to their platform and notify users and whatnot. And here is the linear pipeline. And as you can see, all the steps are going after each other. So we download the track, then we transcribe it, then we enhance the transcription, then we translate in enhanced track, and so on. And this design not only helps to maintain clarity, but also allows for easy scalability and improvement. Each phase in the pipeline plays a specific role in ensuring the content is processed, translated, and delivered in the best possible way. All these chunks are independent of each other, and this plays a huge role in this pipeline. Key technologies. So we use Kotlin here because we are most familiar with Kotlin. We use Podcast4j as a framework for using with podcastindex.org. Whereas podcastindex.org is a huge database of podcasts, and you can ask them about any podcasts, title, description, MP3 track, and, for example, thumbnail, many info you can take from there. And OpenAI API, and we use three models from there. We use Whisper1 to transcribe audio from the MP3 track. We use GPT-4o to work on the transcribed text and to enhance it and to translate it, basically. And then we use TTS1 to convert this translated text into the Russian MP3 track. We use Cater with OkHttp to make all the HTTP requests, whereas Podcast4j has its own client. For the OpenAI API, we use OkHttp. We use Jackson for all the JSON data. We use JavaX XML APIs for building RSS feed. And we are planning to use FFmpeg to merge the chunks of MP3 files. And this will allow us to merge these chunks in a correct way, because if you just merge their content, there might be problems with, for example, playback. You cannot play it from the middle of the track, because each MP3 file has its own metadata, including the length of the track. So you may jump to a wrong place, basically. And FFmpeg allows to merge these tracks to merge the metadata to make the audio levels on the same level, so you don't hear big changes in the loudness, and it just makes audio files more listenable. Podcast downloading. The first step of the pipeline is downloading podcast metadata and audio for new episodes from podcastindex.org using podcast4j library. Once the metadata is retrieved, we can then download the corresponding MP3 audio files. These files are the core content that will be processed in the subsequent stages of the pipeline: transcription, translation, etc. Now that we have podcast information, we can move to the next step, which is speech-to-text with Whisper. And in the next step of the pipeline, we use the Whisper1 API to convert the downloaded podcast audio into text. And basically, we just give the MP3 track to the Whisper1 API, and it returns us the text. One problem with that is that it works well only for files under 25 megabytes. Most of the podcasts we work with are less than 25 megabytes, but there are bigger ones. And if the file is bigger, we have to split it into multiple chunks and then process each chunk independently. This is just the requirement of Whisper1. It just does not accept files bigger than 25 megabytes. It's not a big problem, but it is what it is. Text enhancement and translation. First, GPT-4o enhances grammar, punctuation, and readability here. And for the prompt, we say, context, this is a transcription of a podcast in English, fix the grammar and punctuation, or translate it to English if it's in the wrong language. Detect where podcast starts and cut unrelated content at start. Output format and output with no introduction, only output text. After the text is polished, we send another request to GPT-4o, and this time to translate text into Russian. And the prompt is translate text below to the Russian language. Keep the translation as close to the original in tone and style as you can, and we just give it a text. This way, GPT-4o translates text into Russian while preserving the nuances of the original text. This ensures that the podcast conversational style, humor, and personality are preserved, making it engaging and relatable to the Russian-speaking audience, just as it is to the English-speaking one. Speech synthesis with TTS1. Next, let's dive into the process of converting the translated text into Russian audio using OpenAI's TTS1 model, along with challenges faced in this step. And in this step, we just use TTS1 model with Russian text, and it returns us MP3 tracks with Russian voice. While the synthesized voices are quite good, they still carry a slight American accent, which may not always sound perfectly natural for a Russian-speaking audience. For example, the intro in English might be Welcome to Nature podcast sponsored by X, which is translated to Добро пожаловать в подкаст Nature, спонсированный X. When comparing the original audio, AI is transforming science with a localized version, EE. You may notice that while the translation is accurate, the TTS voice still carries the American tone. This slight accent issue can impact the overall feel of the podcast. Audio assembly challenges. Next, let's dive into one of the key challenges in the pipeline, merging audio files. It may seem like a straightforward task. The process is combining multiple MP3 files presents some technical hurdles. And yeah, as I already said, MP3 metadata conflicts can create playback issues. And currently we're just merging the MP3 files together, taking their byte arrays and merging them together. It may not work properly, but it works if you just listen to the podcast from start to finish. If you try to listen to it from the middle, you may have issues in some players. In others, it might work. And also, different MP3 files may have varying bit rates, sample rates, encoding methods, volume levels, all this stuff. And we need to work on it with FFmpeg, but this is not the priority right now. RSS feed generation. Now let's look at the final step in our localization pipeline, which is publishing the translated podcast through an RSS feed. Two important aspects of the process for distributing the translated podcast is XML-based RSS feed creation and translated metadata for better discoverability. The first one, XML-based RSS feed creation, is about creating the XML with RSS feed and then feed this RSS feed into the podcast platforms so that they can access it, they can see if new episodes, and then they add new episodes to their platform. The second thing is translated metadata for better discoverability. Basically means that we take all the titles, all the descriptions, and translate them to Russian. So people can then easier find what they want to find. Because it would be weird if you have a Russian podcast with English description, right? Some of the core challenges so far were file size limits in Whisper. So we have to split original MP3 files into smaller chunks sometimes. Second one is style preservation in translation. And here we rely on the OpenAI's models and rely on our prompts so that we do not just translate the text as, for example, Google Translate or any other translate platform, but we also preserve the style, preserve the terminology and everything else using the OpenAI's models. And audio merging complexities is just FFmpeg should solve our problems, but it will take some time. In order to ensure high-quality translations, we use various techniques to fine-tune GPT-4o. This includes grammar correction prompt to fix Whisper's output. Handling mixed language content, GPT-4o can translate text into Russian, so there are only Russian words. Tone preservation techniques, we ask GPT-4o to preserve the tone of the text while it translates into Russian. Let's look at the example. And it says the input is AI school and in Russian kruto. Here you can see that we have both English and Russian words. And for the transcript, we will have AI school and in Russian kruto, which is all in English letters. And then we translate it into Russian and get EE kruto. This example highlights how fine-tuning the prompts ensures that GPT-4o preserves not just the meaning, but also the tone and style of the original message. In this case, it ensures that the use of cool and kruto fits naturally within the context and keeps the conversational tone intact in the translation. Maintaining the original tone of a podcast is essential for keeping the audience engaged, and we do this by fine-tuning GPT-4o's translation with specific prompts to preserve the tone. In addition, we select TTS voices that match the energy level of the speaker. Let's explore some examples that demonstrate how we address challenges related to the tone and personalization in translation. On the left, you can see that we use a slight American accent. So the result sounds non-native. It's usable, but we will improve the voice later on. We translate all intros, outros, and ads. We have plans to either remove ads or adapt them for Russian audience, but for now we just translate it as it is a part of a podcast. And on the right side you can see before and after comparison example. AI is transforming science, localized to AE, and it has slight American accent and it doesn't sound that natural to Russian speaking persons. And we also have to work on this part. Quality assurance measures. Currently, we ensure translation accuracy through manual reviews, where we check for nuances, inconsistencies, and tone shifts that automated systems might miss. This helps maintain the original intent and style of the podcast, but the process is time-consuming and not easily scalable as we expand to more podcasting languages. To improve efficiency and consistency in the future, we plan to add an automated quality scoring measures like Blue scores, which compare machine-generated translations to human translations, and native speaker evaluations. Blue scores provide a quantitative measure of translation accuracy, while native speaker feedback ensures that the translation sounds natural and culturally appropriate. These improvements will speed up the review process and help maintain high translation quality as the system scales. And here I will show some of the key code snippets that we have. And this is one of the first parts, which is downloading podcast episodes. We have a podcast ID for the podcast where we want to download. And here we take this podcast, download all the episodes for this podcast, and later we download all the MP3 files for this podcast. Another part is transcribing audio with Whisper, which is pretty simple. And Here we have to take the file, the audio file, and send it to the OpenAI client without any prompts, without anything. And we have to say that we want to use Whisper 1 model. We have to say that we use this specific audio file, and it just transcribes the file and returns us the text. Another one is improved transcription method, which takes the transcription and source language and improves this transcription. And as you can see in the prompt here, it improves grammar and punctuation, translates everything to source language, which is English, if it's in the wrong language. So in the podcast, you may have multiple languages, let's say English and French or English and Russian. And for better understanding, you have to first translate everything to English and then everything from English to Russian. It just works better. And here is another one, generating speech with TTS1. Here we take the text that we want to translate, we split it into chunks of not more than 4,000 characters each, because this is a restriction of the TTS1 model. It cannot generate speech for more than 4,000 something characters at once. So we split into chunks of smaller text. Then we generate MP3 files, and then we merge them together into a single byte array. And this will be our MP3 file in Russian, which we will later use for distribution. Generating RSS feed is pretty simple here, as we use Java's XML library, which is included in Java, and we don't need any other libraries. And here we create the RSS feed in XML format, add the podcast info, such as title, description, link, language, everything. And then we add all the info for the episodes, and it includes title, description, a publication date, enclosure, which is the path, a link to the MP3 file, and some ID which has to be unique among all the episodes in this podcast. For example, output. To wrap up, this is the result of a translation a part of an English podcast into Russian. Notice the American accent in the Russian speech. We're also creating RSS feed behind the scenes for distribution. And now let's hear it. So we have this example in English. Let's hear it.
This is episode 2 of What's in a Name. In the previous episode, we learned how scientists name species and the controversies that can result from those names. But names don't just matter to scientists, they can impact all of us. In this episode, we're moving out of the universities and scientific publications where names are chosen and into the public realm, where names chosen by scientists meet non-scientists.
This was the English version, and now let's go into Russian version. Here you can hear that the Russian speech has this slight American accent, but the translation is pretty close. The text is pretty close, so Russian-speaking audience can just listen to this text, to this speech, and understand what's going on in the original podcast. Future improvements. We've come a long way, but there is still room for growth. Future updates will make this even better. As we refine our podcast localization pipeline, we're looking ahead to key enhancements that will improve efficiency and audio quality. Our next steps include automating episode splitting for better segment control, integrating FFmpeg for seamless audio merging, and developing custom-trained TTS voices to enhance naturalness and authenticity. These improvements will help create a more polished and engaging listening experience for localized content. As we wrap up, let's reflect on key takeaways from this presentation. First, deploying machine learning in real-world applications is an iterative process. We continuously refine our approach based on feedback, performance evaluations, and advancements in AI. This work doesn't stop at deployment, it evolves to meet new challenges. Second, by strategically combining OpenAI's tools, including Whisper for transcription, GPT-4o for translation and text refinement, and TTS1 for voice synthesis, we can achieve high-quality localization while preserving the original content's intent and tone. These AI models work together to streamline the process and maintain consistency across different podcast elements. And finally, there is still room for improvement. Future enhancements such as automated episode splitting, FFmpeg burst-based merging, and custom voice training for TTS will refine the process even further. As we continue developing these solutions, our goal is to make localized podcasts feel as natural and seamless as their original versions. Thank you all for your attention. This project is an exciting step forward, breaking language barriers in podcasting, and we're looking forward to what comes next. Thank you.